Dr. G.S. Mahalakshmi, Assistant Professor, Department of Computer Science and Engineering, College of Engineering, Guindy, Anna University, Chennai. She has more than 13 years of UG and PG teaching experience and 5 years of research experience. She has so far contributed 85 research publications, and her research interests are Tamil computing, artificial intelligence, text and web mining. She is an active member in UG and PG Syllabus Revision Committee and designed the syllabi for Anna University and affiliated engineering colleges for the following subjects: Software Requirements Management, Software Quality Assurance and Testing, Artificial Intelligence, Knowledge Management, Object Oriented Analysis and Design, and Tamil Computing. She has also authored several books, 2 journal papers, 31 book chapters, 3 lecture notes, 3 international conference papers, 36 national conference, and 10 other papers. Dr. G.S. Mahalakshmi is an associate editor of Mimanjari, an official magazine on Tamil computing from INFITT. The books of Dr. G.S. Mahalakshmi are Kanithal Adipadai and Kanini Moriyiyal in Tamil language.
Welcome to the UGC lecture series in computer science. In this episode, we are going to discuss the fundamentals of operating system. We are all familiar with many operating systems. In day-to-day life, we have come across DOS, Windows, IBM OS, Mac, so many other operating systems. Therefore, you must be knowing what an operating system is. There must be some fundamental organization which has to be said about the operating system. Without I/O, an operating system services would be incomplete. Therefore, we are also going to discuss the I/O operations, fundamentals, and the managing of I/O devices by the operating system. And there are memory devices and storage which are inevitable components of an operating system, and there are certain principles behind managing the memory and storage. We are also going to discuss about these in detail. Lastly, there are processes which takes care of the functionalities of the operating system. Those processes can either be created, managed, destroyed. Everything else about the activity of a process is taken care of by the operating system. Therefore, we are also going to discuss about the process and its history inside the operating system. If time permits, we will also look at the evolution of processes, the types, levels, and the variations between the processes inside the operating system. What is an operating system? Operating system is basically an intermediary between the user of a computer and the computer hardware. Therefore, an operating system is neither a software nor a hardware. It is a software which is used to control the hardware. Operating system has certain goals. Number one goal is to execute the user programs and to solve the user problems in an easier manner. The second goal is to present the computer system to the user in an efficient and easy manner. And the important goal of an operating system is going to manage the computer hardware in a most efficient manner. Hardware are different types. There are permanent storage device, temporary storage devices. An operating system should have the built-in intelligence to manage the hardware in a most efficient manner. There is a certain structure with the components of the operating system. The structure goes this way. There are 4 components: hardware, operating system, and the application programs and system programs. System programs is basically which will come inside the operating system itself. Hardwares are certain devices which provide the fundamental skeleton of the computing resources. CPU is one kind of hardware which is very much inevitable. CPU stands for Central Processing Unit. Central Processing Unit houses all the necessary things which are components of an operating system. Next comes the memory. Memory is a storage device. Every data or file which we are storing inside the computer system is stored in memory. Memory is of different types which we will discuss in the later slides. I/O devices are other components, hardware components which are inside the operating system. The operating system takes care of managing the I/O devices in a proper manner. There are certain principles and policies to be followed by the operating system for managing the I/O device. That we are going to discuss those things in the later slides. So, fundamentally operating system is going to be a mediator or which is going to control and coordinate every other software and hardware which is provided inside your computer system. Therefore, operating system has to have some amount of programs which are of higher priority, which are called system programs. The rest of the programs which are of little lower priority are called application programs. Application programs are programs which are directly reachable with the user limit. User in terms, we mean users as people who use the computer system or machines which is connected to the computer system or other foreign computers which is getting connected to this particular computer system. Therefore, application programs get the wish from the external user, translate it to the operating system and get the things done for the user from the operating system. Therefore, an operating system also should have the intelligence of communicating to the application program and getting things from the application program. We have seen many application programs in our life: word processors, web browsers, database systems, video games, and so are called application programs. These are the 4 components of the computer system. Computer hardware is the underlying component. Over the computer hardware, there is the operating system which is going to take care of the control of the computer hardware. Over the operating system, there are 2 types of programs which I have said earlier: system programs and application program. System program and application program in a combined manner, they are going to communicate to the external user in terms of various forms. So, compiler is one kind of application program, assembler is another application program, text editor is yet another application program. Like that, parallelly any type of any number of application programs can be installed in a computer system, and the operating system is going to take care of every application program and is going to take care of the communication between the user and the application program in an efficient manner. There are certain services which are provided by the operating system. Fundamentally, an operating system has to be a intelligent resource allocator. Resource in terms of memory, in terms of files, etc. Everything else which is under utilization is termed to be a resource inside an operating system. Therefore, operating system has to be a manager for all these resources to avoid the conflicts between the efficient usage of the resources. And therefore, operating system makes decisions between requests which may be conflicting for efficient and fair resource utilization. Conflicting in the sense, at the same time, if 2 I/O devices compete for a particular type of storage device, operating system does some calculations internally based on the parameters of that particular I/O device and recommends whether the I/O device is allowed to use the particular hardware immediately or not. Therefore, operating system is going to be a good resource allocator, or in other words, a good resource allocation mechanism has to be built inside an operating system. And next service is controlling. So, OS is basically a control program. OS, an operating system, controls the execution of programs to prevent the errors and improper use of the computer. There may be false execution of a program which may be creating a large disturbance to the kernel memory. Kernel is something which is the core part, like the heart of the for a human. Kernel is something which is the central core part of an operating system. Kernel is something which decides whether this particular operating system is going to do this or that. So, basically operating system does some controlling job also. Everything else inside the computer system, that is inside the operating system, is either going to be a system program or is going to be a application program. So, this is the organization of a model computer system. There is going to be the CPU here. The CPU is getting connected to the disk controller. Disk controller, in terms of so many disk controllers may be available, and every disk controller is capable of controlling many disks available, and there can be USB controller. USB stands for Universal Serial Bus. Universal Serial Bus is a type of interface which is capable of interfacing the mouse, keyboard, etc., printer, etc., etc. There has to be a graphics adapter also, which has to connect your computer to the monitor. So, all these components combined together is called the organization of this particular computer system. The operating system basically takes care of instructions to and fro all these devices and fundamentally manages the user request accordingly. Now, we will discuss how the I/O is going to operate inside. As you can see from this, there may be many I/O devices which can be connected to the computer system via device drivers, via disk controllers. So, I/O devices and CPU can execute in a concurrent manner. For example, internally, while the CPU is processing, it is continuously giving instructions to the monitor, and which is basically an I/O device. It is an output device. It displays instructions to the output device. It also parallelly inputs the instructions which the user gives via the keyboard. Keyboard is basically an input device, and therefore operating system efficiently manages the I/O device and CPU in a concurrent manner. So, there has to be a device controller, or there has to be a controlling authority for this particular thing. So, which is called a device controller. So, device controller is something which is in charge of a particular I/O device. Every I/O device has got a device controller. Worst case, a particular device controller can be shared with the same type of I/O devices with multiple copies if they are present inside the particular computer system. For example, if there are so many mouses connected to the particular computer system, there can be a single controller which is capable of controlling the information which is read from this mouse or the other mouse. So, every device controller is in charge of a particular device type. There can be any number of devices connected to the device controller. Every device controller has a local buffer. Buffer, which we mean in terms of memory. Buffer is going to be a small amount of memory dedicated to the device controller. Therefore, any information which is to be read from the I/O device is kept in the buffer for later use with the CPU, or any information which is output from the operating system to the I/O device is also kept in the local buffer, so that at a later time the I/O device is capable of reading the information from the buffer. Why this concept of buffer comes into picture? There is a speed mismatch between the CPU and the I/O device. I/O device operates at a much lower speed than the CPU, or in other sense, the CPU operates at a very higher speed than the I/O device. Therefore, when the CPU is giving instructions to any I/O device, the I/O device is very much less capable of parallelly interpreting the instructions from the CPU. In other sense, the I/O device is very much less capable of giving instructions parallelly to the CPU. Therefore, there needs to be a speed match or synchronization between the CPU and the I/O device. This synchronization has to come in terms of memory. The reason is the data is getting exchanged between the CPU and the I/O. Therefore, there needs to be a mechanism to house or buffer the data temporarily so that it can be passed on to the next stage at a later time. Therefore, the concept of buffer has come into picture. Buffer is in terms of very small amount of memory in terms of bits. So, therefore, the local buffer is responsible of transferring things, data, or from the CPU to the I/O device, or from the I/O device to the CPU. Fundamentally, the local buffer informs the CPU after it finishes the operation by causing an interrupt. Interrupt is a disturbance basically which is given to the CPU that the I/O device has finished the operation. This is essential because the CPU only now will get to know that the buffer is empty, so that the CPU can put more information at a later time to the buffer. There are two different types of I/O mechanisms available. Number one is synchronous, number two is asynchronous. As I said earlier, synchronization is a mechanism which is very important for the speed match of CPU and I/O device. So, the synchronous mode of I/O transfer goes this way. There is a user which is requesting some operation, and I have already mentioned there is a device driver which takes care of the I/O device. The user gives instructions via some I/O device. Let us say it is going to be a keyboard. User is giving some instructions via the keyboard. The device driver, which is responsible for the keyboard, device driver, remember, it is going to be a software. The device driver reads the instructions from the keyboard and it is going to generate an interrupt, and there is an interrupt handler which is going to take care of generation of interrupt for this particular device driver. This interrupt handler is a part of the system software or system program which is available inside the operating system. Remember, I have already mentioned an operating system. Apart from the kernel part of the operating system, there are two other components, system program and application program. Interrupt handler is one part of the system program. Let us have a short break. We will continue later. Welcome back after the break. We will now resume our lecture on synchronous means of I/O transfer. We have been discussing what the interrupt handler is. Interrupt handler is a part of a system program. It takes care of generating the interrupt for device driver into the hardware of the computer system. Now the interrupt is given to the hardware, and the hardware knows why the interrupt has come and from where the interrupt has come. Therefore, now the data transfer starts because this is a synchronous mode of data transfer, and in this method the data transfer directly starts from the hardware to the requesting process. Therefore, in synchronous mode of data transfer, only the request is given in an offline mode, the transfer is happening in an online mode, and therefore we have mentioned the arrow as a continuous line, and this is the mechanism of synchronous data transfer. In asynchronous data transfer, it is going to be the reverse. The process as usual has requested some amount of data transfer via the device driver. The device driver requests the interrupt handler to generate an interrupt. This is done in an offline mode, and the interrupt is given to the hardware. Now the hardware, having known that there is something which needs to be done, it might be busy in some other work, so the request is postponed, and sometime later when the hardware is capable of doing it, it does the data transfer. This is shown as a continuous line, but actual data transfer does not happen immediately. It is postponed at a later time. It may happen immediately, it may not happen immediately. It all depends on whether the hardware at that particular moment is busy or not. Therefore, we say this data transfer as an asynchronous mode of data transfer. There are two important differences between synchronous data transfer and asynchronous data transfer. For synchronous data transfer, the number one advantage is at a request immediately the service can be got. But for an asynchronous data transfer, the request had to be placed and there has to be a waiting time for the service to be got. It may so happen that the service may come immediately or it may not come immediately. So, these are the two fundamental differences between synchronous and asynchronous data transfer. And now comes the storage structure. There are different types of storages available inside the computer system. The number one storage is the main memory. Main memory is something which houses the hot things inside the computer system, inside the operating system. That is, it is basically a large storage media, but for the CPU. For us, hard disk is the largest storage media, but CPU is capable of accessing directly the main memory in terms of any commands or in terms of servicing the request. Therefore, main memory is a central part of the storage which can be accessed by the CPU. Operating system resides in the main memory. There is another storage is called secondary storage. Secondary storage is basically an extension of main memory. It is basically non-volatile. Volatile means things, volatile in the sense things which are written on the storage are getting deleted as soon as you remove the power from the particular computer system. But non-volatile storages are bound to keep the information, maintain the state of information in them as long as the data is maintained. Secondary storages are very good example of non-volatile storages. We have seen so many types of secondary storage, floppy disk, hard disk, etc. are all called secondary storages. A CPU will not be directly communicating or talking to the secondary storage for want of any data transfer. Internally, a CPU communicates to the main memory, and main memory in terms of commands and instructions communicates to the secondary storage and get things done for the particular operating system. There are also magnetic disks available as a storage media. Right now they may not be used very widely, but even then they are very inevitable components of a storage media. Every disk is basically has got a disk surface. The surface of the disk is basically divided into number of tracks. You must have seen a CD. The surface of the CD is similar to the surface of the magnetic disk. But the thing is, the tracks which are inside the magnetic disk surface are visible. The tracks inside the CD surface are not visible. And the track is a circle is called a track, and every track is being subdivided into sectors. More detailed things about organizing files and storing the files inside the disk and scheduling the disk is postponed until the later slides. There needs to be a disk controller which is going to determine the interaction between the device and computer. As I said earlier, this disk controller is also called device controller in general. This is the hierarchy of the storage device. There are magnetic tapes at one end and registers at the other end. And the other storages which are available in this diagram are cache, main memory, electronic disk, magnetic disk, optical disk, and magnetic tapes. This arrangement of this hierarchy of the storage actually tells you three things. The storage is arranged in terms of speed, in terms of cost, and in terms of volatility. You must be knowing magnetic tapes are very low in their speed when compared to registers. But when compared to storage, registers are very low and magnetic tapes are very high. High in the sense, magnetic tapes are compared to optical disks can store more amount of data. Therefore, registers are the least thing which is capable of only storing a single bit of information. A bit of information in the sense it can be either a 0 or it can be a 1. There is another memory called cache memory, which is a very interesting memory. Cache memory is actually an intermediary memory or a faster type of memory which is capable of giving things to the CPU. In order to match the speed of the CPU, there has been an organization made in this way such that the cache memory reads things from the main memory and houses it like a local buffer does, and it tells things to the CPU whenever it is needed. It also gets things from the CPU whenever it gives. It stores the things and at a later time to the secondary storage device. And here comes the important part of the operating system. A process. Process is something which is a program in execution. A program which is at the executable state is called a process. It has got a life cycle. So, it is basically a unit of work within the operating system. A process is basically an active entity. A program is a passive entity. A process is capable of doing anything inside, or in other words, whatever is considered as a task inside an operating system, can also be said as a process. The process needs certain number of resources to finish its particular job assigned to it. Okay. So, the particular resources may be the CPU, memory, IO, files, etc., etc. Every process needs to initialize itself before the start of its life cycle. All these things happens in the place of process control block, which is basically a data structure which is inside the operating system memory. It houses every information related to the process, which we will be discussed in the later slides. Fundamentally, the process creation and termination has to happen in terms of resources. When a process is getting created, these many resources needs to be allocated. When a process is getting terminated, the already allocated resources needs to be reclaimed. Therefore, the particular operating system takes care of these allocation and deallocation of resources with respect to the processes accordingly. There are activities related to the process. The operating system does certain things for managing processes: creation of process, deletion, suspending the process, resuming the process, process synchronization, process communication, and handling the deadlock between the process. Suspending the process comes in terms of a delay. When a process takes care of some IO operation and the IO device gives quite a long delay in responding, a process needs to get suspended so that some other process can continue with the CPU. When the IO device resumes, the suspended process can be resumed. So, this is basically suspension and resumption of the process, and there needs to be a process synchronization between the process inside the memory. There may be two different processes which are doing the same operation. simultaneously. Data from one process may have to be given to the other process. Therefore, there needs to be a synchrony in between the process in terms of their execution. Therefore, the OS takes care of the communication which is happening in between the process and the synchronization of the process. At times, more than one process may compete for a particular resource. Only one type of resource will be available. More than one process will be waiting for handling that particular resource. At this moment, the operating system comes as a mediator or comes as a judge to decide who should use the particular resource. Therefore, the operating system also takes care of handling the deadlocks between the processes. Now comes the concept of multiprogramming. Multiprogramming is something which is essential in today's operating system. Without multiprogramming, there is no CPUs in today's world. Multiprogramming is basically required for efficiency. A single user cannot keep the CPU and IO devices busy at all times. Therefore, multiple users are connected to a particular operating system, so that every user is actually considered as a single node and the operating system is servicing every user upon his request. Multiprogramming is basically intelligent in organizing the jobs, so that the CPU always has one particular process to execute. The CPU is not kept idle for any moment of time. This is basically seen in terms of CPU utilization. Multiprogramming is a capacity which tries to improve CPU utilization. So, in terms of for multiprogramming, there is always a subset of the total jobs in the main memory. From the main memory, among the set of jobs, certain number of jobs which have higher priority are picked and given to the CPU, so that corresponding jobs are getting serviced in immediately. So, this selection of jobs and running of jobs is basically, that is execution of jobs is basically done via job scheduling. We will discuss job scheduling in detail in the subsequent chapters. When a particular job has to wait for IO, the OS switches between one job to the other job, which we say is called context switching. Context switching may also happen in terms of interrupt processing, and other terms also context switching might happen. However, the operating system takes care of the CPU and its utilization in an efficient manner. It never keeps the CPU idle, it always keeps the CPU busy, such that either one job or the other is being given to the CPU for continuous execution. Now comes the concept of multitasking. There is a difference between multiprogramming and multitasking. Multitasking can also be said as time sharing. This is basically a logical extension. Physically, it is not an available code or algorithm inside the operating system. In time sharing mode, the CPU basically switches the jobs frequently. Remember the word switches. The CPU is getting switched from one job to the other job. The users can interact with the job even while the job is in execution, while it is in the running state or a suspended state. In whatever state a job may be, the users may be able to interact with the job in the time sharing system. The only criteria within the time sharing system is any job which is handled in a time sharing mode has to have a response time within 1 second. We define the response time as the request which is given inside and the response which is got outside to the user. For example, the time taken from the keyboard press to the display in the monitor. It has to be within 1 second for a time sharing system. Every user at least will have one program executable in memory, and we call those programs as processes. And switching between the processes is basically done by scheduling the CPU, which we call as CPU scheduling. If processes do not fit in memory, assuming there are so many processes are there and memory there is only room for holding only 4 processes. So, therefore, there are so many processes available. So, to house all processes it is very much impossible. So, therefore, to house if processes does not fit in memory, there is a concept of swapping which is coming into picture. Processes which are idle or which are less utilized or which are not utilized for a longer amount of time is chucked out of the memory and new processes are brought inside. This particular thing is called swap in. The reverse is called swap out. There is another concept of virtual memory which basically allows the execution of processes. This virtual memory takes care of executing the processes outside the core memory area. Therefore, the load balancing of the CPU is basically carefully maintained. So, in summary, we will be able to say there are certain structures inside the operating systems. Every structure which is inside is bound to have certain services. to enable the efficient utilization of the CPU and to provide the services in an efficient manner, there needs to be certain principles and policies which is housed inside an operating system in terms of algorithms. These algorithms are executed by the CPU. Every such algorithm or every such process which is inside an operating system is considered as separately, and a process can also be called as a task, it can also be called as a job. They are basically logical extensions only, and there are certain IO devices which are available inside your computer system, and operating system also takes care of managing the IO operation. If files needs to be stored, there needs to be a storage device. There are many storage devices inside your operating system. The OS takes care of storing the files into this storage device and retrieving the files from the storage device and managing the storage device accordingly. And finally, there needs to be managing the process in an efficient manner, otherwise deadlocks might occur. Therefore, an operating system takes care of having multi-programming option between the processes, or multitasking between the processes, or multi-processing between the processes. These are basically a logical extension of how a process is getting handled inside the operating system. Now, we will have a set of review questions. OS is a software. Can you say true or false? Operating system is not basically a software. It is neither a hardware also. It is a mediator which is communicating between the software and the hardware. Therefore, to say true would be very much wrong for a first question, but I can never say false also. Basically, if somebody says my OS has become failure, I need to load a next version of OS, we are only loading the soft copy of OS. Therefore, you cannot say OS is a software. OS can never be called as a software 100%, but to some extent you can say you can see OS in terms of a software, you can visualize OS in terms of a software. When you come to the second question, OS is a hardware. Can you say true or false? Never. OS is not at all a hardware. OS is something which takes care of or manages the hardware. Therefore, for the second question, OS is a hardware, the answer is false. The third question is distinguish process, task and job. Basically, the words process, task and job are logical extensions to the computer system. Process is something which is an active program in the memory. Job is also a process only. Task, it is still a process. These are logical names given to the process at one stage or the other. What is resource management? Resource management is something which is basically taking care of managing the efficient utilization of resources and the CPU. In this lecture, we have been discussing the fundamentals of operating system, the operating system services, structure of operating system, components and storage management. In the forthcoming lecture, we will be discussing about the multiprocessors, the types of multiprocessors, the variations and the operation of multiprocessors in detail. Thank you.